Hi guys, welcome back to Chem 101 with Moods. Now, don't forget to leave your questions in the comment section and we'll be sure to look at those in the next one. Welcome back to Chem 101 with Moods. Don't forget to leave your questions in the comment section so we can get to those in the next one. This week, or lesson number 2, we're going to be looking at the heating and cooling curve. Now, the heating and cooling curve is basically a graph of temperature change over time or against time. Now, on our y-axis, we plot temperature, and then on our x-axis, we would plot time. So the heating and the cooling curve, it can be represented on one graph. So the forward graph or the forward reaction would represent our heating curve, and the reverse would represent our cooling curve. So let's look at this. Let's dive in. So if we start out with a solid, if you notice on your y-axis, we're increasing temperature. If we notice on our x-axis, we're increasing time. So as time progresses, we're increasing temperature. Or solid, we keep heating, and then we have a flat line. This is where our solid melts. Our solid melts, we're still increasing heat. We keep heating until we come to the liquid phase. I'm still increasing temperature, time is still moving along, I'm still heating. Eventually I flatline, and that is where my liquid starts to vaporize. If I continue to heat some more, I end up with a gas. Now if I look at the reverse of this, I am reducing temperature, because if we look at our y-axis, we notice that temperature is decreasing. So if I started out with a gas and I'm cooling my gas, I keep cooling, it starts to flatline, and that's where my gas begins to condense. I'm still cooling my gas, I'm still cooling. Eventually I'm going to end up with a liquid. So now that I have a liquid, I'm still decreasing my temperature, I'm still cooling down my system. Eventually my liquid is going to freeze, and I'm going to end up with a solid. Now, if we look at our graph, we notice that we have two sections that are flat-lined. They are my melting or my freezing point. That is the same point, that's right here. And my other flat line represents my boiling point. Now, the minute we hear the word point in our definitions, we need to think about constant temperature, and that's where our flat line is represented on our graph. So the melting point is a constant temperature at which a solid is converted to a liquid. My freezing point is the constant temperature at which my liquid is converted to a solid. My boiling point is the constant temperature at which my liquid is converted to a gas. Now, at the actual points, we say it's a constant temperature, because if you notice, if you should check the temperature at varying points along this line, we're going to end up with the same temperature. It is constant here, it doesn't increase or decrease, so we have a flat line. The next thing that we need to take note of is that our melting point and our freezing point is the same. So if we're using water as an example, then the freezing point of water is 0 degrees Celsius. The melting point of water is also 0 degrees Celsius. And I should be sure to mention that it's pure water. If I add any form of impurities to my water, then it's going to lower the melting point. It's going to lower my freezing point. Consequently, though, if I add any impurities to water, it's going to increase my boiling point. So impurities lower the melting point, it lowers the freezing point, but it increases the boiling point. So 3 takeaways from this before we go is that our melting point, point here being constant temperature, so our melting point is the constant temperature at which or solid is converted to a liquid, or freezing point is the constant temperature at which a liquid is converted to a solid, And our boiling point is the constant temperature at which our liquid is converted into a gas. That's going to be all for today. Join us again next week for another video. And don't forget to put your questions in the comment section. Also, like, share, and subscribe. Bye-bye.